Well, let's go ahead and kind of sum up what we've been talking about the past couple of days. First and foremost, I want to make sure we understand the difference between area and volume. When we're asked to find area, I just want to reiterate, we're drawing in our slice. All right, and if our slice is vertical, I want to make sure we're all saying upper minus lower. Now, volume, we're going to start revolving things when we find the volume. We revolve them around a certain axis. Okay, and they'll always tell you what axis, whether it's X, Y, or just a general line. Now, when we talk about volume, we have to distinguish whether we first have a disc or a washer. So let's kind of break it down and talk about the two. If I have a disc, okay, my whole function, let's say it looks like this. This whole area, you'll notice, is sitting right on the axes of rotation. Okay, there's no gaps. This whole thing is right on there. If I have a washer, let's say I'm going to revolve it around this axis. Okay, now this shaded area, you can clearly see that there is a big gap here. Okay, and the moment we have a gap, it now becomes a washer. Now, the formulas are similar, but again, let's get them written down. If I have a disk, my volume is just pi r squared dx. Okay, obviously from my lower bound to my upper bound. If I have a washer, okay, here's where it changes the game. We have volume equals pi, the integral from a to b, and we've got to consider big R squared minus little r squared. All right, and lastly, let me just focus in once I draw in my rectangle, okay, and let's put those big dots on the ends. We make this very clear. My big R goes from the top of my dot to the axis of rotation. That's my big R. And my little r goes from the bottom of my dot there to the axis of rotation. And that's how we describe our big R minus little r. And again, I just want to stress we're saying upper minus lower each time.
So lastly, I just want to be very clear that when we describe big R and little r, we are describing the bracket that we draw in. Okay, so my upper bound is here, my lower bound is here. My upper is here, my lower is here. Make sure you are describing the brackets.
All right, so let's go ahead and take example 1. And we're going to do several things to it. First and foremost, we need to get this sketched out nicely. Okay, and this is a non-calculated question at the moment. So I want to sketch this out. I'm just going to plug some numbers in for 2 to the x. Now we get the general shape down. We know it's exponential, but let's plug some numbers in. If I plug 0 in, anybody to the 0 is 1. If I plug a 1 in, 2 to the first is 2. If I plug a 2 in, 2 squared is 4. Obviously, you get the idea. This function is increasing. Okay, negative x plus 8. Now, hopefully we all know this is the equation of a line with a negative slope. So I'm going to say it looks like this. This picture is not drawn to scale, I want to reiterate. I have y equals 0. I'm going to change colors here. I like everybody to be in a different color. And for those of us that are forgetting, that's a horizontal line, y equals 0. We won't name any names. And then we need an x equals 0. And again, I'm going to change that to a different color to make it even more obvious. Okay, that is a vertical line. So the area that we're finding needs to be shaded by all of those lines. All right, now again, when you have the colors, it's extremely obvious. The area that's between the blue, the pink, the red, and the green would be this section here. All right, now before I go any further, of course, I need to get all these points of intersection. All right, so I'm going to start with this point here. Hopefully is very, very obvious. That would be 0, 0. This point here, I hope is very obvious. That should be 0, 1. Okay, this point over here, basically, it's when negative x plus 8 is equal to 0. So it would be at x equals 8. So that would be 8, 0. Now this point here isn't as nice to find, so we're going to go ahead and find that with our calculator. So we need to get the intersection, and that's the intersection of 2 to the x and negative x plus 8. So I'll pause it for a moment, grab your calculator, and let's get that point stored into alpha a. And I actually want you to do 2 things, all right, because we're going to use both the x and the y value. So we know once you get that intersection, do your x store into alpha a, and I just want to be clear, my number was approximately 2.467, blah, blah, blah. And then I want you to do the same thing. I want you to hit alpha y, and that y is just their alphabetical order. I think it's alpha y1. Take your y value and store that into b. My b value turned out to be 5.4 5, 3, 2, 1, blah, 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 blah. And I'm going to use those A and B values. Now that I've identified them on paper, it's fair game to call it A and B the rest of the time. All right, so here's our first question. We need to find the volume when we revolve this area around the x-axis. Okay, now, I picked a nasty one on purpose. All right, I'm going to get another color just to make this stick out even more. Let's see. All right, now when I put my vertical, well, first of all, let's make a notation on the x-axis. So I want to be perpendicular to the axis of rotation. When I put this vertical line in, ask yourself, is this one line good enough for the whole picture? Is my upper always red and my lower always blue? I hope you're saying no. Clearly, when I get to this point, my upper changes from red to green. And again, that's why those colors are so useful. So we know I have to write two integrals. Now the next thing we need to talk about is, do we have a disk or a washer? Is your area sitting completely on the axis of rotation? Since I don't see any gaps, let's be very clear that this is a disk. Okay, and since this is a disk, the first thing I'm writing down is volume equals the integral of pi r squared. All right, now let's go get our radius. And remember, we have to write two of them. So I'm going to start with my first one that I have in orange here. And I'm going to say I'm going to integrate that sucker from, I can go to the left till I get to 0. And I can go to the right till I get to a. And it's upper minus lower. So I'm going to pull my pi out, upper minus lower squared. Now my red line is the 2 to the x minus the lower is on the blue, which is 0. And it's that chunk squared dx. Okay. Now I have to add on another integral. All right, this time, I'll put my line in black here, my slice. I'm going to pick that up from a and go until I get to 8. And again, let's say upper minus lower. The upper is on the green line, which is negative x plus 8, minus the lower, which happens to be 0. You don't really need to say that. And it's that chunk squared dx. Now, I'm going to make a note just underneath this that I have this stored in y1, I have this stored in y2, so be very careful when you type that in. I would type it just how you see it, pi, math 9, 0 to a, y1 squared dx, plus pi, etc., y2 squared dx. You can pause it, see what you get. I end up with 244.391 for my volume revolved around the x-axis. Question 2. Find the volume when revolved around the line y equals negative 3. Now, we don't need to go crazy. I want you to take the same picture, but make a quick sketch of it. So pause it. I'm going to go back and steal mine and get that same picture. All right, so we've got the same picture now, and we're going to change the game. We're going to revolve around y equals negative 3. So I'm going to go ahead and draw that line in. Y equals a nice horizontal line, negative 3. Okay, now this time, are you a disk or a washer? Look at your shaded region. Is there a gap whatsoever between your shaded region and what you're revolving around? Of course there is. So this time we have a washer. Anytime we have that gap. All right, now again, this is a nasty problem because of the two intersections. So let me get that first one cooking. All right, let's get our our vertical line perpendicular to the axis of rotation in. And now let's carefully draw in our big R and our small r. Okay, and it's very simple, guys. You put two dots on your vertical line. You go from the top dot to the axis of rotation and you put a big R. Then you go from the bottom of your dot to the axis of rotation and you put a little r. Now you have big R minus little r. All right, so let's go set it up for that first red vertical slice. All right, so I'm going to say my volume equals, because I'm a washer, let's make a little cheat sheet, pi integral big R squared minus little r squared. All right, so this red guy is going to go pi, and this guy can go from 0 to a that we called it. Okay, now I need big R squared minus little r squared. So I'm going to put a big bracket and then parentheses, let's get big R. My upper, I'm describing the bracket, the upper is on 2 to the x. Minus the lower is on negative 3. And together, obviously, that makes a positive, and it's big R squared minus, now we'll describe little r, and again, describe the bracket. The upper is on 0, you have to put that there, minus the lower is negative 3 squared. So it's basically positive 3 squared. Close my bracket, slap a dx on the end. Okay, we're describing the bracket. All right, if you're not getting this, write that down. You are describing the bracket. All right, now that's just the first piece. Remember, this one's ugly. We also have, let me put the black line in over on this side. So I have to add to that the next one, okay, because this one was split. So let's go ahead and put our big R and little r on this. Okay, big R from the top of your vertical slice to the axis of rotation. Little r, bottom of your slice to the axis of rotation. So I'm going to add on pi, the integral, from a to 8. All right, now I need big R. So look at your upper minus lower of your bracket. My upper is negative x plus 8 minus my lower, which is negative 3, so I can say plus 3 squared, minus, now I need little r, 0 minus negative 3 squared, which of course is positive 3, dx. Okay, that's a mouthful. This is going to take a bit of, talent and practice here to type that in the calculator. So make sure you pause it and you can do this yourself. Again, I make little notes to myself. This is in my Y1, this is in my Y2, and take your time, pause it, plug it in, and see what you get. I got, 656.083. Okay, now if you're not getting that for some reason, make sure that this function is in its own parentheses minus this function in its own parentheses. If you know 3 squared is 9 in the top of your head, obviously you do. You don't need to do that math. You can just put 9 in. All right, now I've got an even nastier one for you. This says find the volume when revolved around the line x equals 10. All right, so I want you to steal that same sketch, pause it if you need to go slow down and sketch it out again. And let's go ahead and draw in x equals 10. Okay, so clearly that line would be over here. Now this, I'm telling you, requires a lot of slowing down and self-talk. First of all, do we have a disc or a washer? Does your shaded region have a gap, or is it clearly sitting on the axis of rotation? Okay, I hope it's very obvious to you that there is a gap, so that creates the washer, the donut-looking shape. Okay, so the second I see that, let's get our game plan down. That's the integral of pi, big R squared minus little r squared. Okay, now remember, you need to be perpendicular to the axis of rotation. All right, therefore, if my line is a vertical line, okay, my slice needs to be horizontal. So when I go to draw this in, I need to have a horizontal line. And that makes a whole new ballgame, guys. When we have that horizontal slice, this is where it gets a little annoying. We have to get new bounds. Well, we have to get y bounds. Okay, so things have to be in terms of y, and our functions have to be in terms of y. All right, so let's slow down and say, okay, is this one slice good enough? Will my right side always be on green and my left side always be on pink? Well, nope, that's not the case, so I need to, draw the second one in. All right, now let's go ahead and make our bracket. The nice part is you're saying the same thing every time. Okay, it's either upper minus lower, right minus left. So in this case, I'm going right to left. So I'm going from one end of the dot that I made on my slice to the bracket. That is your big R. Go from the other dot to the bracket. That is your little r. All right, still chugging here. We need to rewrite these equations. Okay, so let's slow down. The green one was y equals negative x plus 8. Okay, it has to be in terms of y. This function is currently in terms of x. It has an x in it. You need to resolve this equation. So basically, I'm going to add the x over here and bring the y over there. So I'm going to say x equals 8 minus y. Okay, and box that in. That is now my green equation. Okay, that goes with this function. I also need to do the same thing with my y equals 2 to the x equation. I no longer can use 2 to the x in the problem. I need to have it in terms of y. Okay, now we just saw this on our quiz last week. How do you solve this equation for x? Well, it's exponential, so you need to take the log of both sides. When I take the log, that brings that exponent down in front, basic log properties. And then when I solve for x, I'll get the ln of y divided by the ln of 2. And that's what I need to use when I see this pink equation. Okay, so we're finally ready to actually write our integral here. So I'm going to say volume equals pi, the integral, let's talk bounds. Let's start with this bigger one that I have my radiuses drawn for. This function can move up and down, not left and right. So I would say it can go as low as here, which has a height of 0. So my lower bound is 0. And it can go as high as this point where they intersect here, and that has a height of 1. So I can go from 0 to 1. And now let's describe that bracket. Big R squared minus little r squared. And remember, you read right to left. The right side is 10 minus, this is sitting on 0, squared, plus, oops, big R squared minus, sorry, little r. Okay, little r is sitting on 10 minus this green curve. And we said the green curve is now 8 minus y. Okay, other little trap, don't put a dx, make sure you put a dy. Now we have to add on to that because we need to get the volume of the slice for the next piece. All right, so let's go ahead and draw this in. Let's grab a blue dot here. All right, so I have to go from one dot to the axis of rotation, that's big R, the other dot to the axis of rotation, that's little r. Okay, now the bounds, this can go from a height of 1, it's got to pick up where this one left off, and it can go up till they meet here, and we said that point, remember, was a comma b, which we stored in earlier in the game, so I'm going to call that b. All right, right minus left, start on big R. Its right side is on 10, minus its left side is on my pink line, which we said was the ln of y divided by the ln of 2. It's that chunk squared, minus little r would be 10 minus the green line. This is not squeezing in. So I'm going to say that's 10 minus my green line was 8 minus y. All of that squared, and slap a dy on the end of that. Okay? Now, here's the one trap you got to be careful on when you do this on your calculator. You can't use y1 and y2 anymore at the moment because this function is not in y1, so keep that in mind. So if you want to erase what you currently have in y1 and y2, that's fine. And in y1, I'm going to put 8 minus y. Obviously, I have to use an x on the calculator. And in y2, I'm going to put the ln of x divided by the ln of 2. Now again, I can't use the ln of y. Your calculator can't do that. It only understands the letter x. Now, I think you should pause it, make sure you can type that in. This is definitely a common AP question. Try it and see what you get.
I end up with 893.240. Well, that does it for us. We'll see you tomorrow.